So we have, let's say this is on the floor, okay? That's on the floor. And we have another vector that's sticking up from the floor. Okay, so yeah, let me make the parallelepiped. Alright, it's not perfect, but good enough. Okay. That's the parallelepiped. Okay. Now, because this is actually a prism, do you guys realize this is a prism? If I cut this anywhere like this, if I cut it, and if I look at this, it's going to be the exact same surface as the bottom, and whole way through. Any prisms is base, right? Base times height. So I assume that you know this much. I hope that's a fair assumption. So if this vector down here is A and this is B, we already learned that the parallelogram at the bottom is this: A cross B, like that. That's the area of the bottom. Okay, so this is the bottom area. Alright, now I need to multiply that by the height. And here's where I get the height. I draw a normal. I draw a line that's perpendicular to both A and B. So that's the line that represents that. And what I'm going to do is, to find the height, I'm going to project this vector C onto this perpendicular line. Right? Then you get the exact height of this parallelepiped. Okay, so if I call this right here C, this right here, and let's call this theta. This is C magnitude cosine of theta. Okay, let's call this here N for normal. I'm just giving it a name, this one, N. So this here, so look, N dot C, by definition of dot product, is the following. So that right there can be isolated, which is what we have here. Okay, so this is the height. So let's multiply that here. Well, what's N? N is this. Cross product and you get the N. So let's replace it now. So that's not a magnitude, this is a vector. And this is a magnitude. Cancels out because they're both magnitudes. So this is how you get volume of a parallelepiped. Now the second part of the question is asking, well, how do you know if this and this is the same? Or can you show that it's the same? So BC is actually treating, so I just did this part here. BC is just treating this as your base, right? And if that's the base, like that will be the height. So I project this onto here, and you're finding the area of the parallelepiped that way. It's the same volume. We're finding either whether you do it this way or this way, we're still finding the volume of the same shape. So they must be the same. Continued my notes from here. I should have said this times by the height And what I'm saying is the height is this. And then the next step is this one.